Hello, as we get ready for our subtraction test that's coming up, wanted to provide you with a brief video showing how to regroup and give you some background knowledge as you work through some problems and try and understand it. So here we have this problem, 12,738 minus 10,479. And if you remember when I did the addition video, I showed the problem broken out into expanded form, so I'm going to do the same here. Taking both of our numbers, 12,738 and 10,479, and breaking them into expanded form. So if we take a look over here, I'll blow this up a little bit more for us. So you see here we have both numbers in expanded form. So as we have spoken before, we always want to start with the smallest place value. In this case, it's the ones place. A little pointer, it's the ones place right here. When we move into decimals, whichever decimal place is the smallest, that's what we would start with. But because we've got the ones place here, that's the smallest. All right? So we must not forget our subtraction sign. Even though we have these addition signs here, this is only to show the number itself in expanded form, not to say that we should be adding 8 and 9 together. So don't confuse that. So first, let's subtract 8 minus 9, subtracting 9 from 8. Now, a lot of people will say, well, you can't do that. Well, that's technically not true because we could do that. We could show it as a negative number. 8 take away 9 would be negative 1. But with this particular strategy, the standard algorithm, when we break it, or when we condense everything back into standard form over here, that's really big, there's no way to write a negative number in our solution down here. There's no way of writing a negative number in the ones place. So to avoid doing that, we need to regroup, or borrow as it's sometimes called. So we will take our ones place and switch some numbers around, reorganize our numbers so that we have enough ones to subtract 9 from. So the way we'll do that, we'll look one place over. That's all we need. Focus on the tens place right here. So all we'll need is to take one of these tens and shift it over into the ones place. So now we're going to take one of our 3 tens here, one of them, and shift it to our ones place. So let's show that. Going to move one of these tens. When I take one, we will now have 2 tens left, or 20. We move it to our ones place. There's no longer 8 ones, 18 ones. 1 10 is the same thing as 10 ones. Just like if we were to show how many hundreds make a 10. 1 100 makes 10 tens. 1 1000 makes 10 hundreds. 1 10,000 makes 10 1000s. So each time we shift it over, we have to remember that it's 10 times. We're adding 10 each time we move it over. Okay, so now we're in a position to where we can add. Now I want to point out something. In our expanded form, we have 30 plus 8, which makes 38. Looking up to what we just regrouped, we have 20 and 18. This is still the same number. We still have 38. 20 and 18 still make 38, but now we have reorganized it in a way that's easier to subtract. So now we have 18 minus 9. 18 minus 9 makes 9. I'll continue to write it in expanded form. So now we're moving on to the tens place, gradually moving larger to the larger places. So we have 20, 2 tens minus 7 tens, 70. So again, we're at a place where we have a negative number. 20 minus 70 would be minus 50, negative 50. So when we're in the standard algorithm, we don't have a place to write negative 50. So we need to regroup here. We need to take one of our hundreds, just one. Take one of our hundreds. When we do that, that leaves only 6 left, 600 left. We take the 100 that we borrowed and add it to the tens place. So now we have 120 or 12 tens. And we can subtract now. 120 minus 70 makes 50. 600 minus 400 makes 200. 2,000 minus 0 is 2,000. And the kids will say, I'm leaving out the commas. Yes, I know. And 10,000 minus 10,000 is nothing. Now, it's not necessary that I write that 0 in, but just to show, 10,000 minus 10,000 is 0. All right, now we have our expanded form answer of 2,259. So in all of the cases where we borrowed, we still end up having the same number that we started with in the very beginning. 10,000 plus 200 makes 12,000. 600 plus 120 makes 720. Plus 18 more makes 738. So now we have 12,738. Same as we started with. Okay, well now I want to shift over and take a look at borrowing across zeros as we refer to it. So here we have a number, 20,359 minus 14,824. And in this case, we have a problem which we will run into once we get to the thousands place. There's a 0 here, okay? And a lot of times, kids will freak out when they see a 0 here. Well, what do I do there? How do I get around that? All right, well, let's go ahead and subtract. I'll use a different color this time. 9 minus 4 is 5. 50 minus 20, 5 tens minus 2 tens makes 3 tens. I can get my numbers right. There we go. 300 minus 800. All right, here we are again in an instance where we would have a negative number normally. And since this is the standard algorithm, we don't have a place to write the negative number. So we need to look to regroup to where we have a number that we could subtract from. So ordinarily, we would take a look at the next place value over. In this case, it would be the thousands place. But there's nothing to borrow from. So what do we do? Where do we go from here? There's nothing to borrow from in the thousands place. So we go to the next place. We move all the way until we find a place that has something we can take from. In this case, it's the 10,000s place. So we're going to take one of these 10,000s. Now, a lot of times I'll get a question, well, why can't I just take this 10,000 and move it all the way over to the hundreds place? Well, if you think about it, that would be taking 10,000 and adding it to 300. So it would be like saying we have 103 hundreds. Now, there's no way that we can subtract and fit the solution to 103 hundreds minus 8 hundreds. There's no way we can fit that many hundreds all in one place. There's only room for 9 of them. So we take the 10,000 we borrow and shift it over one place, just like we spoke of before. So let's show that. Take one of those 10,000s, that only leaves one left, and we move it, shift it to the next place. Now keep in mind, remember, this is the thousands place that we're moving it to. 1 10,000 makes 10 1,000s. Okay? Now remember the goal here, we're working on subtracting the hundreds place. Now we do have some hundreds. Now we have now we have thousands that we can move to the hundreds place. So we have 10 of them now, 10 1,000s. So let's take one of these thousands and move it to the hundreds place. So 1,000 taken from 10 will only leave 9 thousands there. And if we move it over to the hundreds place, there will no longer be 3 hundreds, there will be 13 hundreds. So now we are in a place where we can subtract. 1300 minus 800 leaves 500. 9,000 minus 4,000 leaves 5,000. And 10,000 minus 10,000 leaves no thousands. So our solution, the difference here for this problem, 5,535. You may notate it a little bit differently. You may notate when we borrow, depending on how you were taught in school. This may look a little different, and that's okay. You may take the 1,000 that you borrow and place it right here next to the 3, and that's okay too. Just so long as we're notating and showing how many of each place we have left. Okay? So I hope this is helpful. If you have any questions or comments, if there's something that's a little bit confusing or I was not very clear on, please let me know. As always, thank you so much.